Today I'm just going to go through a couple of examples from the beginning of a rational function all the way to graphing it. And that should help you answer questions that are left on WebWork. So let's just start with kind of an easier one. Okay, we know it's rational because we have a function in the numerator, a function in the denominator. That's what defines a rational function. Where are, well, let's factor, I guess, the bottom first. Minus 2, x plus 1. So no common factors, so no holes. So we know the vertical asymptotes happen where? And don't forget, it's always a line. Okay, what is the degree on top and the degree on bottom?
0.
Yeah, the horizontal is going to be 0 because the degree on top is less than the degree on bottom. So the horizontal asymptote is y equals 0. My zeros, my x-intercept is actually at 0, right? Comma 0, because this is a y equals. So I set this equal to 0. So that happens actually at the origin. No other zeros. My y-intercept, when x is 0, y is what? 0. So only time all place it goes to is at the origin. What else would be helpful here? That's at 0, 0. At this point, I have a vertical asymptote at 2 and negative 1. I have a horizontal on the x-axis. And I have 1 point on there. Okay. So to get a sketch of it, I'd kind of like to know, I know it's going to go through this point, but I don't know if it's going to go through from the right to the left or the left to the right. So what I'm going to do is just put in a point, or it could just go up and back down. I don't know. It could be a little parabola. So I need to get an idea of a couple points in this section, a couple points in this section. Do you see how it's split into 6 sections? Okay, so there's going to be something either in this or this, not both. And something in this section or this section, not both, and something in this section and this section, but I don't know what the shape. So at this point, I'm just going to have to put numbers in for x that are in those intervals and just kind of see what the values of y are, so I can get a couple of points and get a general feel. Okay. So let's start with something negative infinity to negative 1. So let's just say negative 2. Negative 2 over negative 2 minus 2 times negative 2 plus 1 is negative 2 over negative 4 times negative 1 is just positive 4, negative 1/2. So at negative 2, I've got a point that's going to sit right there. I probably, even with that, that's enough to sketch it for me. Because I can see it's going to go to that horizontal asymptote. It's going to go to the vertical asymptote. So that's kind of what it should look like. I just knew it was in that bottom section, so I could just sketch it. We could do a couple more points and get it real precise, but I just want you to be able to sketch them. In calculus, if you ever use it, it's helpful to be able to visualize what the graph looks like when you're doing limits. And we're going to do limits, actually, at the very end of this semester. So this is helpful. Okay. Let's do one between. And I'm probably going to go something less between 0 and negative 1 because I want to know if the shape is going to be a parabola, if it's going to be something that goes like this. I don't know what it's going to be. So let's just go negative 1/2. Negative 1/2 over negative 1/2 minus 2 is negative 2.5, which is negative 5/2. And negative 1/2 plus 1 is just 1/2. So that's negative 1/2 over negative 5/4. So when I divide by a fraction, I multiply by its reciprocal, so negative 1/2 times negative 4/5, which is 2/5. So it's positive at negative 1/2. So let's see what it is at 1. 1 over negative 3, negative 1, sorry, times 2, so that's negative 1/2. So to me, it's going to be, looks like it's going to do something like that. Making sense? Okay, and then finally, this part is either going to be some shape down here or some shape up here. So let's just pick 3. Three minus 2 is 1. 3 plus 1 is 4. 3/4 at 3. So I'll call it like that. And I picked an example from this book, and you can see what the graph looks like. We sketched it pretty well. Okay, just picking some points. Does that make sense? Okay. So let's do another one. Let's do x squared minus 9 over x squared minus 2x minus 3. Okay, so first step, factor everything. X minus 3, x plus 1. So I have a hole. Where's my hole at? At 3. So what I'm going to do is ignore these two and just plug in 3 here and 3 here. So I have 6 over 7, right? So my hole happens at 3 6/7. Did I do that right?
Wait.
6 over 4. Let's try that. 3/2. That's a little better. Okay, so there's my hole. Now, to find my zeros, it's no, yeah.
What do you do if, like, on the top number, it's just like a constant number?
Uh-huh.
There's no x,
It's not a rational function then.
so you just put like none for the holes?
Yeah, there'd be no holes. Okay, well, I guess it still is a rational function. But, okay, so now I am not going to use this or this, so my 0 happens to be at negative 3. Call it the x-intercept. Okay, y-intercept is when I set everything equal to 0, it looks like it's going to be 3 over 1. Right, when I put 0 in for x. Zero, 1. What did I say it was? 3. Okay, let's work on asymptotes now. What's my vertical asymptote? It's a line what? X equals. No, these are canceled. Those are holes. Those aren't asymptotes. Just negative 1. Yep. You're not going to have an asymptote where you have a hole. Okay, and I can just cancel these. Then you do the rest of the work with that. Okay. Now we look at the original function. What is the horizontal asymptote? 1, because they're the same degree, so you just divide the leading coefficients. Okay. Horizontal asymptote, y equals 1. Okay. So we have enough to kind of get an idea of what information we're going to need still. Hole is at 3, 1.5. X-intercept is at negative 3. Y-intercept is at 3. vertical asymptote is at -1, and horizontal asymptote is at 1. I'll do that in red. So, I think I'm going to have something in this section. It's going to look like that. This section, actually, just with what I have, I might have enough to just kind of sketch that in. And there's the graph. Kind of getting the feel for these. Okay. Once you have these main points identified, you kind of know the shape. You're never going to have something in the same sector that overlaps the x-axis. I mean, that's overlapping the asymptote. So you're not going to have something here and here, or not, I'm sorry, here and here, or here and here. It's going to be one section or the other. So once you kind of get it broken out into the sections, you know what points you have, what points you still need to really get an idea of what the shape's going to look like. That makes sense? Okay. You mean to do another one, or you want to just work?